last video, you have studied about force, types of forces, and effects of force, inertia, and stripes. Let's see a new topic in this video. Let's learn something interesting. Take a book and place it on your palm as shown in the picture. We feel a downward force on our palm, which is exerted by a book. The force spread over our entire palm. Now try to place the book only on your pointer finger as shown in the figure 2. We feel a force again, but it presses harder because this time the force is acting on our finger, which is a smaller area as compared to our palm. So, are force and pressure related? Yes. Pressure is interrelated to force, or we can define pressure as a force acting on a unit area. Again, I am repeating, we can define pressure is a force acting on a unit area. Presently, we are considering only the force acting on an area in a direction perpendicular to it. According to this, the force exerted perpendicularly on a unit area is called pressure. I am repeating again. The force exerted perpendicularly on a unit area is called pressure. Pressure is equal to force upon area on which the force is applied. Let's see the unit of pressure. Pressure is equal to force upon area. What is the unit of force? It is Newton and area meter square. So pressure is equal to Newton per meter square, which is denoted by one word Pascal, that is PA. Factors on which pressure depends. First, magnitude of force applied. More the force applied, more is the pressure. Second, surface area. Greater the surface area, lesser will be the pressure. Lesser will be the surface area, greater will be the pressure. This we can understand with the help of following example, that is a blade and a knife. A sharp knife has a very thin edge to its blade. A sharp knife cuts bread or fruits better because due to its very thin edge, the force of our hand falls over a very small area of the object, producing a large pressure. This large pressure cuts the fruit or any bread easily. Now let's see pressure on solid. Air pressure is exerted on all the objects kept in air. When a weight is kept on a solid, pressure is exerted on it. This pressure depends upon the value of the weight and the contact area between the two. As you see in picture, when the books are kept separated, the pressure exerted on the rod is less. When all these books are kept together in center, okay, the weight is increased, and due to that the pressure exerted was more on solid. Of liquid. Liquids have weight and they exert pressure on the walls of the container. Pressure exerted by the liquid at the bottom of the container depend on the height of the column. Pressure exerted by the liquid increase with depth. The pressure in a liquid at a given depth is dependent of direction. At the given depth, a liquid will exert the same amount of pressure in all the direction. You have to perform here one activity which is given in the textbook, page number 17 and 18. Try to do this activity at home in the presence of parents. Gas pressure. Let's understand it with one activity. If a balloon is inflated by filling air by mouth, it inflates on all sides as shown in figure A. If a pinhole is created in the balloon, air leaks out and the balloon does not inflate fully as shown in figure B. Through it we realize that like a liquid, gas also exerts pressure on the walls of the container in which it is enclosed. I am repeating again. It is realized that like a liquid, Gas also exerts pressure on the wall of the container in which it is enclosed. All gases and liquids have a common name, fluid. Fluids in a container exert pressure from within on the wall and the bottom of the container. A fluid enclosed in a container exerts its pressure equally in all directions at a point within the fluid. Atmospheric pressure. The earth is surrounded by a layer of air. This layer is called the atmosphere. The atmosphere extends up to many kilometers above the surface of the earth. The pressure exerted by this air is called atmospheric pressure. For understanding this, we will look at the image 1. Imagine that a very long hollow cylinder of unit cross sectional area is standing on the surface of the earth and it contains air, as in the picture A you can see. The weight of this air is the force applied in the direction of the center of the earth. This means that atmospheric pressure is the ratio of this weight divided by the area of the surface. The air pressure at the sea level is called 1 atmospheric pressure. As we all are knowing, atmospheric pressure can also be defined as the force per unit area exerted on the surface of the weight of the air above it. It is maximum at sea level and decreases with height. You can see in the picture number 2, at the sea level the air pressure is higher. As we move above the sea level, the air pressure is getting lower and lower. So at high altitude there is a lower air pressure. Now let's see the new force, buoyant force. Buoyant force is a force by which liquid exerts an upward force on a submerged object. Buoyant force depends upon two factors. First, volume of the object. The buoyant force is more if the volume of the dipping object is more. Second, density of liquid. More the density of liquid, more is the buoyant force. Let's understand the buoyant force with this activity which is given below. Take a plastic bottle and fix the lid tightly. Now place it in a water and see. It will float on water. Try and push it into the water. Even when pushed, it continues to float. This experiment can also be done with a plastic hollow ball. Now fill the bottle with water to the fullest capacity and close the lid and release it water. The bottle will float inside the water. Why does this happen? The empty plastic bottle floats on the surface of water. On the contrary, the bottle full of water floats inside the water but does not go to the bottom. The weight of the empty bottle is negligible as compared with the weight of the water inside. Such a bottle with water neither floats on the surface nor does it go to the bottom. This means the force due to gravity acting downward, that is the Fg force, you can see in the picture, must have been balanced by an opposing force in the upward direction, that is Fb force, on the bottle filled with water. This force must have originated from the water surrounding the bottle. The upward force acting on the object in water or other fluid or gas is called buoyant force. Now next topic is Archimedes principles. For understanding it, let's do one activity. Look at the picture carefully given in the slides. Take a long rubber stand and cut it at one point. At one of its ends, tie a clean washed stone or of 50-gram weight as shown in picture. Now hold the other end of the rubber band and make a mark there. Keep the stone hanging in air and measure the length of the rubber band from the stone to the mark made earlier. Now Take water in a pot and hold the rubber band at such a height that the stone sink in it. Again, measure the length of the rubber band up to the mark. What is observed? This length is shorter than the earlier length. While dipping the stone in water, the length of the stretched rubber gets slowly reduced and is minimum when it sinks completely. What could be the reason for the shorter length of the rubber band in water? When the stone is sunk in water, a buoyant force acts on it in the upward direction. The weight of the stone acts downwards. Therefore, the force which acts on it in the downward direction is effectively reduced. How much is the magnitude of the buoyant force? Is it the same for all the liquid? Is the buoyant force of equal magnitude for all objects? The answer to these questions are in the Archimedes principle. Then what this principle states? It states when a body is partly or fully immersed in a fluid, it experiences an apparent loss in weight which is equal to the weight of the fluid displaced by the submerged part of the body. The use of this Archimedes principle is very wide. The principle has been used in the construction of ships and submarines. The instruments such as lactometer, hydrometer are based on this principle. This principle you are going to study very detailed in ninth and 10th standard. Density of substance and relative density. Density is equal to mass upon volume. The SI unit of density is kg per meter cube. The property density is very useful in deciding the purity of the substance. The relative density of a substance is expressed with the density of water. Relative density equal to density of substance upon density of water. This being a ratio of two equal physical quantity, it has no unit. Relative density of a substance is called its specific gravity. Let's see some solved examples. First, the area of the bottom of a tiffin box is 0.25 meter square and weight is 50 Newton. Calculate the pressure exerted by the box on the shelf. What is given here? Area equal to 0.25 meter square. Weight of the box 50 Newton. Pressure is not given, that will come question mark. So solution, pressure equal to force upon area equal to force is how much, that is equal to the weight, that is 50 Newton upon area 0.25 meter square. After calculation, the final answer we are going to get is 200 Newton per meter square. So the pressure is equal to 200 Newton per meter square, or you can say 200 pascal. Presently, we are considering only the force acting on an area in a direction perpendicular to it. According to this, the force exerted perpendicularly on a unit area is called pressure. I am repeating again. The force exerted perpendicularly on a unit area is called pressure. Pressure is equal to force upon area on which the force is applied. Let's see the unit of pressure. Pressure is equal to force upon area. What is the unit of force? It is Newton and area meter square. So pressure is equal to Newton per meter square, which is denoted by one word Pascal. Now let's see the new force, buoyant force. Buoyant force is a force by which liquid exerts an upward force on a submerged object. Buoyant force depends upon two factors. First, volume of the object. The buoyant force is more if the volume of the dipping object is more. Second, density of liquid. More the density of liquid, more is the buoyant force. Let's understand the buoyant force with this activity which is given below. Take a plastic bottle and fix the lid tightly. Now place it in a water and see. It will float on water. Try and push it into the water. Even when pushed, it continues to float. This experiment can also be done with a plastic hollow ball. Here we come to the end of this chapter 3. The assignment of this chapter will be given separately. All have to solve the assignment in this science fair notebook. Thank you. Have a nice day. Take care.